When you walk through an old cemetery, you see all the names and dates, and you can't help but wonder about the lives they lived. But what if I told you that a cemetery is way more than just a quiet place of rest? It's actually a massive historical database. And the secrets hidden inside can tell us this incredible story about how we live, how we die, and how in a very short time, everything changed.
I know, it sounds a little strange, right? Using clues from the distant past to try and understand our future, but that's exactly what we're going to do. Think of it like this. We're data detectives, and we're about to unlock a story that's been waiting for centuries, a story that's literally carved in stone.
All right, so our investigation starts right here, among the tombstones. We're on the hunt for clues that are hidden in plain sight. Clues that, when we put them all together, reveal a pattern that's way bigger than any one person's life. Okay, so this is the key. Every single one of these stones is more than just a memorial. It's a data point. It gives us a birth year and a death year. Now, one stone by itself, that's a personal story. But when you collect hundreds of them, together they start to tell the story of an entire population. So, to make sense of all this raw data, we need a special kind of tool. It's something ecologists and demographers use all the time to visualize the story of survival itself. And it's called the survivorship curve. So what exactly is a survivorship curve? Well, it sounds complicated, but it's really not. It's just a graph. It starts with 100% of a population at birth. Then it simply tracks what percentage of that group is still alive as they get older. It's a picture that answers a really basic question. What are your odds of making it to the next birthday? Now, out in nature, you basically see three main patterns of survival. Let's start with type 3. Think of something like an oyster. They have millions of babies, but almost none of them make it. So that curve just plummets right at the start. Then you've got type 2, which is like a straight diagonal line. This is for animals like squirrels, where the risk of dying is pretty much the same their whole life. And then there's type 1. And that brings us to us. We humans are a classic example of a type 1 curve. Most of us survive childhood and adulthood, and most deaths happen when we're old. But here's the million-dollar question, the one we're here to answer. Has our story of survival always looked like this? The cemetery data? That holds the key. Okay, this is where our investigation gets really interesting. We're going to take all that data from the tombstones in the US and split it into two groups, everyone who died before the year 1900 and everyone who died after. First up, let's look at the curve for the folks who lived and died before 1900. The first thing that just jumps right out at you is that steep initial drop. A huge chunk of the population didn't even make it past their early years. This tells you that just surviving childhood was a massive, massive hurdle. Now, watch what happens when we plot the data for people who died after 1900 right on top of it. Whoa, it is a completely different story. That curve stays high and flat for decades. That huge drop in childhood almost disappears. I mean, this isn't just a small change. It's a total revolution in what it means to be human. Let's just put these two worlds side by side for a second. Before 1900, you have incredibly high infant mortality, a pretty tough middle age, and a much shorter life overall. After 1900, infant mortality just plummets, most people are surviving well into their golden years, and the average lifespan shoots way up. The difference is just staggering. So what on earth happened? What was this incredible force that completely reshaped our lives in such a short period of time? Well, the answer isn't just one thing. It was a whole collection of world-changing breakthroughs that all happened around the same time. This is what changed everything. We figured out that clean water and sewers could stop killer diseases like cholera. We invented vaccines for illnesses that used to wipe out kids, and antibiotics for infections that were basically a death sentence. We got better food, better nutrition, and we even learned that something as simple as washing our hands could save lives. But if we had to pick the single biggest game changer, it's this. By far, the most impactful thing was just saving the lives of the youngest people in our society. That massive drop in deaths for infants and children had this huge ripple effect that lifted the entire curve up for everybody. Okay, so now that we know how to read these curves, we can use this tool to analyze all kinds of different situations and even get a glimpse of what the future might hold. So let's try a little thought experiment. If we were to go and plot a survivorship curve for a developing country today that doesn't yet have widespread access to modern medicine and sanitation, what do you think it would look like?
Well, odds are it would look a whole lot like that pre-1900 curve from the US. You'd see that same tragic drop-off in the early years. But here's the good news. We know exactly what to do about it. Things like healthcare, vaccines, and clean water can push that curve up and to the right, moving it toward that modern shape we see in developed countries. But what about the flip side? Let's imagine a negative scenario. What if environmental problems get worse in a developed country and lead to more diseases caused by pollution? How would that change our nice, flat curve? Well, you probably wouldn't see that big drop at the beginning. Infant healthcare is still really strong. Instead, the damage would show up later. You'd likely start to see a dip in middle and old age, a faster drop-off, as things like cancer or respiratory diseases take a greater toll. It's a pretty sobering reminder that all this progress we've made isn't necessarily guaranteed. All right, let's zoom out one last time. This whole story of survival that we've been piecing together, it's a really crucial part of an even bigger puzzle, the story of how entire nations grow and change over time. So how does our survivorship curve fit into the grand scheme of things? Well, it's a key piece of something called the demographic transition model. This model basically shows how birth rates and death rates change as a country develops. And you see that falling death rate in the early stages? That's our survivorship curve in action, and it's what drives these huge shifts in population.
So, back in the 1800s, the US had high birth rates, but its death rates were falling fast. That's stage 2, which leads to explosive population growth. But then, as we moved into the 1900s, death rates stayed low and birth rates also started to fall. This moved the country into stages 3 and 4, where population growth starts to slow down and eventually stabilize.
And there you have it. We went from a simple date carved on a single tombstone to collecting the data to plotting a curve. We saw how that curve tells this amazing story of human progress. And finally, we saw how that story fits into the larger narrative of global population change. It's all connected. So I'll leave you with this to think about. 100 years from now, what new chapter in our story will be written in stone? Will incredible medical breakthroughs push that curve even further to the right, maybe letting most of us live past 100? Or will new challenges like climate change or new diseases cause it to dip back down? The data for that story, it's being created right now with every single life being lived. What do you think it's going to reveal?